Good morning, dear students. Today we are going to deal with the numericals of chapter 4. So in this chapter we have three formulas. First formula we will start with the work done. Work done is equal to force into distance or force into displacement. Force also we can say that our weight of our body is acting as a force. So the both force and weight, it is almost the same. Then the second problems is related to potential energy. P is equal to mgh. And the third one is kinetic energy, half mv square. So first we are going to start with the numericals related to work done. Work done is force into distance or displacement. Question number 1. A force of 30 Newton, force is given 30 Newton, acts on a body and moves it through a distance 5 meter. In the direction of force, calculate the work done by the force. So it's a direct application. Work done is equal to force into distance or displacement. 30 into 5 will get 150 joule. Work done. Work and energy have the same unit. Any energy, either potential or kinetic or mechanical or work done, everything has the same unit. It is 150 joule. Question number 2. A man lifts a mass 20 kg. So mass is given 20 kg. In the first question directly it was given force. But here only mass is given 20 kg to a height 2.5 meter. Height is given 2.5 meter. Assuming that the force of gravity on 1 kg mass is 10 Newton. That is, we are given a hint to convert kilogram mass to weight or mass to force. So how will you convert mass to force? You just want to multiply by 10. Here it is given in the question. 1 kg is 10 Newton. So what will be 20 kg? 1 kg 10 Newton means 20 kg. 20 into 10, 200 Newton. So we convert mass into weight, or we have the formula W is equal to mg. Anyway, we can substitute. Weight and force both are same. So mg is equal to 200 Newton. So we got force as 200 Newton and the distance is already given 2.5. So how will you calculate work? Work is equal to force into displacement. 200 into 2.5. Answer is 500 joule. Next, question number 3. A body when acted upon by a force 10 kgf moves a distance 0.5 meter in the direction of force. So 10 kgf. Kg and kgf both are the unit of mass, not the unit of weight or force. So here again, as we done in question number 2, we convert kg to Newton. How we done that? 1 kg 10 Newton. The same way, kg and kgf are same. Absolutely no change. Kg is the unit of mass. Kgf is the gravitational unit of mass. But both have the same magnitude. 1 kg and 1 kgf both are same. So as we convert for the question number 2, 20 kg is 200 Newton. Same way, 10 kg, how will you convert? 10 into 10, we will get 100 Newton. So we got force as 100 Newton and the distance is given 0.5 meter. So you are asked to calculate the work done. Work done is equal to force into distance. 100 into 0.5. You will get 50 joule. Question number 4. So the first 3 questions were related to the work done by a body. Now we are going to do with the second set of questions, problems related to potential energy. As I already told in the beginning, formula for potential energy is mgh. Here m is the mass, g is the acceleration due to gravity and h is the height. So I'll read the question number 4. Two bodies of same mass are placed at the height h and 2h. Compare their gravitational potential energy. Now you have to keep in mind whenever you got a numerical question related to compare, the word compare means you are asked to find the answer is ratio. So we are going to compare the gravitational potential energy of a body kept at a particular height. So you just imagine here one ball is the another ball. I took two balls. The mass of two balls is same and the acceleration due to gravity is same for all the objects under this universe. So G is also same. But the first ball I kept at a height 1 meter and the second ball I kept at a height 2 meter. You are asked to compare their gravitational potential energy. As we already completed our theory part, we studied how does this height depends on potential energy. Greater the height or higher the height, greater is the potential energy. So from the question it is clear which one will have more potential energy at a height h or 2h. It will be obviously 2h, twice the height. For comparing, mgh is to mgh, E is to ratio. So since the mass is same, we can write m. Gravity is also same, so both sides we can write g. But height here it is given in the question h and 2h. So here I am writing simply h and 2h. Both LHS and RHS, the general terms get cancelled. Mg can cancel, here Mg cancel. So what remaining here? H. H means simply we can write 1h. 1 into h is h. Here 2h. Again h and h cancel. Remaining the ratio of their gravitational potential energy is 1 is to 2. Next, question number 5. Find the gravitational potential energy of 2.5 kg mass kept at a height 15 meter above the ground. The force of gravity on mass 1 kg is 10 Newton. So here 1 kg is given 10 Newton. We can do the problem in two different ways. One way is we can directly convert mass into weight. W is equal to mg, mass into gravity, 2.5 into 10. Or we can write gravity separately as 10 meter per second square. Because here it is given mass of gravity, force of gravity on mass 1 kg is 10 Newton. That means acceleration due to gravity is given 10 meter per second square. So you are asked to calculate potential energy mgh, mass into gravity. Okay, 10 you have to write here, gravity into height. Just multiply all the three, 5 into 15 into 10. You will get the answer 375 joule. Question number 6. The potential, the gravitational potential energy stored in a box of weight 150 kgf. Here it is given weight 150 kgf. So if it is written weight also, from the unit it should be clear. Kgf is the unit of mass. So mass is given 150 kgf is 1.5 into 10 raised to 4 joule. So potential energy is already given 1.5 into 10 raised to 4. For doing the calculation easy, we can convert this as the normal number. So 1.5 into 10 raised to 4 means 10,000. 1.5 into 10,000, you can remove one decimal. You will get 15,000 joule. I am just converting 1.5 into 10 raised to 4 as a normal number. I am just removing the power of 10. So you will get 15,000 joule. So potential energy is given, mass is given. You are asked to find the height. So mass, first we have to convert mass to weight. Weight is W is equal to mg, mass into gravity, that is 1,500, 150 kgf, 150 into 10, 1,500. That is weight. So potential energy is mgh. From here, h is equal to potential energy divided by mg. Here mg is mass, weight is equal to mass into gravity, mg. W is equal to mg. That always keep in mind. So here when we are writing potential energy directly also, we can rearrange the formula as this mg is weight. So we can write here weight into height or instead of weight we can say force. Force into height. Any way we can write. Keep in mind, mass into gravity is weight, or mass into gravity is force. So H is equal to P by mg. Potential energy is 15,000 and mg or weight is 1,500. So 15,000 by 1,500, you will get the answer 10 meter. Next, question number 7. The potential energy of a body of mass 0.5 kg increased by 100 joule when it is taken to the top of a tower from ground. If force of gravity on 1 kg is 10 Newton, what is the height? So here again mass is given. So how will you find weight? W is equal to mg, mass into gravity. It is given 10. 1 kg is equal to 10 Newton. So 0.5 into 10 we will get 5 Newton. Potential energy or change in potential energy is given 100 joule. Find height. So P is equal to mgh. From here how will you calculate h? H is equal to Pe by mg. Potential energy is given 100 and mg, mass into gravity, that is weight. As I told in the question number 6, W means mg. It is 5. So 100 divided by 5. We got the height of the tower as 20 meter. Question number 8. So the problems related to potential energy is over. Next we are going to start with the numericals of kinetic energy. Kinetic energy is equal to half mv square. So question number 8. A body of mass 60 kg, mass is given 60 kg, is moving with a speed 50 meter per second. Speed or velocity we can write 50 meter per second. Calculate the kinetic energy. Kinetic energy is equal to half mv square. Half into mass into velocity square. Mass is 60. So half into here 2 and 60 will get cancelled. Here it will be 30. Half into 60, that is 30. So 30 into 50 square. 50 into 50. 5 into 5, 25 into 3, 75. 3 zeros. You will get 75,000 joule. Next question number 9. A truck of mass 1000 kg, mass is given 1000 kg, increases its speed from 36 km per hour to 72 km per hour. That means initially a vehicle is moving with a speed 36 km per hour. Then gradually it increases its speed and it reaches 72 km per hour. That means its speed increases. So obviously what will happen? Its kinetic energy will also increases. We are asked to calculate the increase in kinetic energy. But here there is one problem is that here velocity is given in kilometer per hour. It is kilometer and hour is not the SI unit. SI unit of velocity is meter per second. To convert kilometer per hour to meter per second, we have 36 kilometer per hour. We know kilometer. How to convert kilometer to meter? How will you convert? We have 1000 meter is 1 kilometer. So instead of kilometer, we can write 1000 meter. And instead of hour, it is 60 into 60. 60 minute into 60 second makes 1 hour. So 1000 by 60 into 60. So we will get 36. Here 2 zeros and here 2 zeros get cancelled. So what remains in the numerator? 10 and denominator 6 into 6, 36. So 36 into 10 by 36. Now we can cancel. We can directly, if you want, we can cancel here. But we have to cancel here because 10 by 36, when you cancel, you will get 5 by 80. So we get a short form. Whenever we need to convert kilometer per hour to meter per second, just multiply the given value by 5 by 18. No need to do all the steps. You have to by heart this for converting kilometer per hour to meter per second. The given value into 5 by 18 gives the value in meter per second. So 36 into 5 by 18. 18 and 36. 18 into 2 is 36. So it will get cancelled. 2 into 5, 10 meter per second. So we got 36 kilometer per hour. Converting to SI unit will become 10 meter per second. Same way we are going to convert 72 kilometer per hour. So here again we don't want to do any steps. As I told earlier, just multiply the given number into 5 by 18. 72 into 5 by 18. So 72 and 18 will get cancelled. 18 into 4 is 72. So 18 ones are 18. 18 into 4 is 72. 4 into 5 20. So we got 72 kilometer per hour is equal to 20 meter per second. Now we are asked to calculate increase in kinetic energy. So half mv square minus half mv square. This is v1 and v2. So half m, it is common. The same object or same vehicle is moving. So mass is constant. So we can take it outside. Half m into v2 square minus v1 square. Half into mass is 1000. So half into 1000 into 20 square minus 10 square. This half and 2 and 1000 get cancelled. You will get 500. 500 into 20 square is 400. 10 square is 100. So 500 into 400 minus 100. 500 into 300. You will get 1,50,000 joule is the change in kinetic energy. That means here we are finding how much energy change, increase take place. The increase in kinetic energy is 1,50,000 joule. In the textbook it is given 1.5 into 10 raised to 5. Either you can write as a power of 10 or you can write the same value 1,50,000 joule. Next question number 10. A car is moving with a speed 15 km per hour and another identical car is moving with the speed 30 km per hour. Compare their kinetic energy. Here two speeds are given and it is mentioned two identical cars. We are asked to compare. As I told you in the beginning, compare means we have to find the ratio. Since we are finding the ratio, no need to convert it into SI unit. If you convert also, no problem, you will get the same answer. Since it is comparison, just want to write the two values. So identical car means mass is same. So comparing half mv square is to half mv square. So half m and half m. Since mass is constant, we can cancel half m, half m. So what is remaining? V square is to v square. First v is 15, second velocity is 30. So 15 square is to 30 square. If you want, you can directly write the value of 15 square and value of 30 square and reduce. Or I think it will be easy for you. 15 square means 15 into 15. 30 square means 30 into 30. Now we can cancel LHS and RHS. 15 and 30 will get cancelled. 15 into 1, 50. 15 2s are 30. So here 1, here 2. Again the same cancellation with the second number. 15 ones are 15. 15 2s are 30. So what remaining? 1 into 1, 1. 2 into 2, 4. So the ratio of their kinetic energy is 1:4. Next question number 11, it is related to power. So the fourth type of problem, first we done with work done. Work done is force into displacement. Second one, potential energy, mgh. Third one, kinetic energy, half mv square. Now the fourth type, power. Power is work done divided by time. Question number 11, a pump raises water by spending the energy 4 into 10 raised to 5 joule in 10 seconds. So energy is given. We already studied in the beginning of this chapter, energy is the ability to do work or the capacity to do work. And this energy and work done are relative. So energy means work done, both are same. It is given 4 into 10 raised to 5 joule. So I am just converting as a normal value, you will get 4 lakh joule. And the time is given 10 seconds. So power is equal to work divided by time. Work is 4 lakh divided by time 10 seconds. So the SI unit of energy is joule, SI unit of time is second. No need to convert any unit. here you can cancel 1 0. Finally you got 4000. And the SI unit of power is watt. W-A-T-T. So we got the answer 40,000 watt. Second question, last question, question number 12. It takes 20 seconds for a girl A to climb upstairs while the girl B takes 15 seconds for the same job. So here two girls are there. Here the mass of the girl is not specified. Since the mass is not specified, we can assume that both are considered to have same mass since it is not specified. And it is given they done the same job. That means they are doing the same job. That means they are taking object to a particular same height. So the time taken is by the girl A is given 20 seconds and that of second girl is only 15 seconds. Our question is to compare their work done and compare their power. Work done, since it is given same job, then the work done will be also same. So we can directly write, therefore work done is also same, that is ratio of work done is 1:1 because in the question it is mentioned same job. So we can write 1:1. Now we have to calculate the power. Both will have different power because the first girl took 20 seconds but the second one she took only 15 seconds. So from that itself it is clear who will be doing the work faster because the second girl within 15 seconds she completed the work. So obviously the second girl will be having more power. So we are asked to compare their power. Power is equal to work done by time. Here work is 1:1. So 1/20 is to 1/15. Work done, power of the first girl, 1 by time taken by the first girl, and here by the second girl 1/15. Now 1/20 is to 1/15. We can cross multiply. You will get 15 into 1. 15 is to 20. While cancelling, we will get 3:4. That means the power developed or the comparison between the power of girl A to girl B is 3:4. So we come to the end of this chapter. The last numerical is over. Hope all of you understood. Thank you for watching.